In December 2023, the Idaho National Laboratory received its first shipment of spent commercial nuclear fuel rods in decades. Designed by Westinghouse and irradiated in a commercial light water reactor, the fuel rods represent the next generation of nuclear fuel technology. The fuel is part of an ongoing effort by the Department of Energy and nuclear industry to design and test advanced fuels.
The end goal is to be able to run our current reactors for longer. Because if you can run a cycle for longer, or you can leave a fuel pin in for more cycles, you end up saving millions of dollars on operating the reactor.
INL's role is to analyze and test the fuel, providing data for licensing. But first, many experts had to work behind the scenes to coordinate its delivery to INL. Shipments of this caliber require safety measures, detailed inspections, and coordination between several parties, significantly contributed to by INL experts.
The meeting started about a year in advance for this particular shipment. Team starts with monthly meetings, and then as we get closer, it's bi-weekly, and then for the last month or two, maybe weekly meetings.
When the fuel was ready for shipment, experts transferred it into a large cask designed for transporting nuclear fuel. The cask was loaded into a trailer to be hauled by a team of experienced drivers.
Just looks like a trailer with a cargo container on it, a large cargo container. You would never know what was actually in there.
In addition to all the other checks and balances for such a shipment, personnel from the state performed required inspections before they hit the road.
They actually get on a mechanic's roller board and roll underneath the trailer and truck and check everything on the truck.
During the trip, INL experts kept in close contact with the various teams to ensure smooth delivery. Finally, after years of planning and coordination, the shipment arrived in the middle of the night at INL's Materials and Fuels Complex. The shipping team could officially pass the baton. Then it was up to experts at the hot fuel examination facility to unload the cask and begin processing the rods.
The cask comes into the truck lock at HFEF, and it's on a flatbed trailer inside of a cargo container. So once we get the trailer in HFEF in the truck lock, we have to start disassembling it from the shipping configuration to get it to where we can mate it up to the hot cell.
Once ready, the cask was lowered through a hole onto a cask cart in the facility's basement, tasked with transporting the cask under the hot cell where it was connected to the main cell. Then, INL hot cell operators use robotic arms called manipulators to remotely handle the irradiated fuel rods.
I am actually responsible to pull the penetrations inside the hot cells and then go down and pull the fuel out of the cask remotely using remote handling equipment. So we're using the manipulator, working through 4 feet of glass and a shielded window. That's the initial process to get them into the facility, and then from there it gets distributed all over throughout the hot cell for the different operations and process.
At this point, INL experts could start taking a closer look at the fuel. The first step was the visual examination machine.
We have a camera that is inside of the hot cell wall, and we can snap the pictures from outside the cell. They're pretty extensive with 12.5-foot fuel elements, so it was like hundreds of photos per element.
Experts then cut the fuel rods using the data from these various analyses, including a precision gamma scanner. This instrument detects the different levels of radiation along the rod to help determine the best locations to make cuts for various tests and examinations. To observe microscopic changes in the fuel cladding, operators mounted small cross-sections of the cladding in resin. Other rod segments were sent to various examination windows, and some were destined for refabrication and accident testing.
I've been working on a process called refabrication. So this is where we take the full-length commercial fuel pins, characterize them, and then we section them into testable lengths and essentially weld them shut again.
During this process, operators created a miniature version of a light water reactor fuel rod by removing a small amount of fuel from both ends of a rod segment and resealing it. After attaching instrumentation and inserting the refabricated mini rod into a specialized experiment testing assembly, the experiment went into the transient test reactor, or TREAT. TREAT is a specialized reactor that applies controlled short-term bursts of intense neutron flux to fuel experiments to see how they respond to accident conditions.
It's very similar to how the automotive industry does crash testing. Like, you designed all these safety systems, you should know they work, but they still crash the cars to demonstrate that they work. That's the same type of thing we're doing here, but with crash testing fuel.
With both fuel refabrication and accident testing capabilities, INL is positioned to provide proof of concept data for new nuclear fuels and change the world's energy future.
It's a huge interest to the entire world, and this is the center of it.